Hi, G. Trulia here from TST. I'm along with
Pierre Respo
and Bill Fickthorn.
So today we're looking at this great pressure transducer kit, the PDS 500X, okay, from Ditex. This kit here comes with a couple of things. So we're using the flexible hose currently in this car behind us, but it comes with this hard metal piece, and Bill, can you hold that? Also comes with these different connectors. Now, if you're going to use one of these different connectors, I highly recommend, even though it has a nice end on it, you see this end? It's nice in case you get it stuck in there, but take a couple of wrenches, don't King Kong it, but I would say give it a good snug fit. That way when you screw this into the engine, you don't leave this part behind. Now, Pierre, we had something that's super important that you want to speak about.
So here, these adapters, you know, you have the normal length 14 millimeter spark plug thread, but you also have the deep reach ones. And if you pick the wrong adapter, you could do engine damage. You could bend valves or whatever, hit the piston. So you got to make sure that you don't use the long adapter when you don't have a deep reach cylinder, you know, or spark plug thread in the head. So just be aware of that. We used the shorter one. That was the same. It's in the car right now. So
it's out of the car now. Just took it out.
Yeah. So you see, the right depth. There'd be no conflict with the motor.
Put it up there again.
So I'm going to put both of them up. Spark plug, deep reach, and the shorter one. So just be aware of that. This is common sense stuff. With any test tool, you just got to make sure it's the right application for what you're doing.
So it does come with a flexible one as well here. Now, a couple of things with the flexible one. One, this end, Bill, maybe take that off and show them. It's a little warm. Just took it out of the motor. So here's the piece that goes on, because if this doesn't go directly in the cylinder, then we need to add this. And again, I'd highly recommend not King Konging it. There is a rubber gasket there, but give it a little snugness with the wrench. That way you don't leave it in there.
And by the way, this is true of all pressure transducer setups with engines. You don't have to really crank the adapter into the head either. It's just got to be snug enough to seal.
Exactly.
And your pressure transducer is going to get the information. You're not going to leak any pressure.
Right.
And then you get your test results.
And in case you're trying to use your compression gauge hoses, you have a Schrader valve in the end. These cannot have a Schrader valve in the end. So if you're going to use a hose, let's say it's a different fitting, whatever, you need to remove that Schrader valve. Here is their pressure transducer setup. And I don't know, Doreen, can you get that real good? And it has a button here. This button here, this is 35 bar, 500 PSI. Hit the button. Bill, you got better eyes than me. I think that's 200.
In is 200.
Out is 500.
So it changes the resolution. It connects with an XLR. Now you go, what the hell's an XLR? We're not talking about a Cadillac XLR. But this here is like for audio. Okay, and I know that from one of our TST board members, Rich. He knows a whole bunch of stuff about electrical connectors. This is going to fit right into here. And of course, this will connect to the pressure transducer. Also, this piece right here does come off. I think that's the right one. Does come off because this is in the kit. It'll fit different connectors. So
and by the way, so it's not just for looking in cylinder like we're doing here. This is, all those adapters are for going into anything that'll have pressure or vacuum on it. So there's a whole bunch of fittings in the kit for that.
Direct connector, you can do vacuum.
And
you got vacuum
you'll
tees.
make your own set of connectors for special applications. Right. You know, you'll have a box of them eventually.
And Pierre, why don't you talk about this thing?
Okay, so this kit has an adapter. What you're supposed to do is screw the spark plug, assuming that you're going to keep the ignition functioning, not what we're doing here today. Oh, yeah, take that stuff. You're going to keep the ignition functioning. You don't want that coil to just fire into the air. You'll damage your ignition coil. So you're supposed to screw your spark plug into here, ground this, And now you're just firing into dead air, basically, with your spark plug, as if you had a dead hole, effectively, no compression, and it won't damage the coil. So that's the whole idea.
And we should say this comes separated, so you need to just screw it in.
Right.
It's no big deal. This came like a separate wire. And again, that's for that. Now, if you have coil on plug, as we have on this car, and Doreen, come close to look at coil on plug that Bill will point to. And you can actually get the coil right from back there, Bill, up top. This is a coil on plug, and if you unplug the wire, as we have down there, Bill, point to that, you're not going to get any spark, so you wouldn't need to necessarily use that.
Yeah, you'll be open circuit at that point.
So that being said, we are going to screw the pressure transducer into the cylinder. We're on a 2005 Honda 1.3 motor hybrid, okay? Now we're in the intake side, and you're going to see why I'm saying we're in the intake side, because we want to show you something. This is a mistake commonly made. We're going to set the scope up and go to the big screen over there. Pierre will start the car up. And one big thing is our sensor must be zeroed. And this is an absolute, correct?
Yes.
I think it said this was an absolute sensor. Now, one of the things we want you to be aware of, okay? You may go, well, that looks like dog do. Stop. It's not dog do. This is actually something that is a good reading because we're on a totally different type of engine.
Additionally, this is a dual ignition engine, and for this demonstration, this part of it, we're showing it to you with an actual combustion event happening in the cylinder. So this doesn't look like what you may have seen in the classes for a dead cylinder, because this cylinder is actually contributing on one spark plug right now.
Right. So with the interference in the background, that's going to be a lot of this stuff here. We're going to do two things before we get to that. First of all, Bill, let's go down from 5 volts to make it bigger. And where are we on the pressure transducer itself? Are we on 200 or 5?
500.
So we're on 500. So let's look at it there. He went down to 2. You see how big it makes it? Bill, go to 500.
200, yeah. Right.
200, right? 200 on.
Now you're going to have to decrease the size.
So now he's going to have to go up with that. Remember, anytime you lower the voltage, your screen gets bigger. So for old guys like Pierre and I, well, you want it bigger because we can't see worth the damn, right?
Yeah.
So we're going to leave it on that and let you look at this for just a second here. So you're wondering, these are your towers, and you go, well, how do I know what the pressure is? We'll let Bill explain that in a minute. So Bill, why don't you come over here and explain your conversion.
So on the sheet that comes with the transducer, we have the 500 PSI range and the 200 PSI range. The 500 PSI range, the ratio is 20 millivolts is 1 PSI. So right now we're on the 200 PSI range, so that one's going to be 50 millivolts is 1 PSI. And
So-
it turns out if you take the 200 or 2400 millivolts and divide it by the 50, you're at about 60, divided by the 50, you're at about 60 PSI running.
You remember, every 1,000 millivolts make 1 volt. So that conversion, it's not that hard. So that being understood, we know we're about 60 PSI or a little more here or there, give or take a little bit. One of the other things is, obviously, if you want it to steadier, we're triggering, and let's see if we can, lock that in a little better. We are in the background on an E-scope, but you can use this on any scope. If we put this on Pico, it'll work. We know there's a video online for Pico, so we didn't use Pico. I do have a Pico. We can put it on Snap-on, and you can see this is stable, but Snap-on, we would need a converter from B&C. It's a B&C connector to banana. We could have done that, but we decided to use this. Now, all of this is interference. This has 2 sets of plugs, intake and exhaust. If we roll over, Doreen, Bill will point out the second set, so you're going to have to go way in. That's the back set of coils. Okay? That's the back set of coils. Now we're going to shut the vehicle down. So remember what this looks like. You can come back on this, Doreen. Okay, and Pierre is now disconnecting, if you put it over there, he's disconnecting the coil wire. Okay, good.
Yep.
We're ready to start up. So now you don't see as much interference. You see nicer towers, exhaust pocket, intake pocket. There is some interference in here, but here's what we came up with. And you guys can come over and chime in. We came up with, if you get used to using a certain piece of equipment, you're not going to worry so much about all of this little hash. And again, this motor being a different type of motor, being a hybrid, we got more interference under there. Remember, we do have an IMA, integrated motor assist, throwing out a lot of high voltage.
Yeah.
We're not going to get into what a different pressure transducer looks like. It's going to have its own signature, just like any scope has its own signature, right? So Pierre or Bill,
So really
chime in.
what you're going to do for this kind of testing, you're going to use that formula to find out your compression number, running compression number. You know, make sure you're at 0 here. If you have a big tail and it's not supposed to be there, that would indicate some failure. I call it failure to exhaust. Maybe an exhaust restriction in the cat, maybe something else. And you're looking for the pockets to see what your vacuum was in the pocket as well. That's really that you're looking at the numbers. You're doing the conversion basically 3 times on each waveform. And then you could run cursors to figure out what the number of degrees were between events. This is 720 degrees, 360 is over here somewhere, and your 180 is here, and the 540 is like somewhere there. You'd have to get accurate with cursors to do that, but that's what you would use to figure out cam timing or individual lobe timing.
And if we did have a problem, Bill, what would you look for here in the exhaust?
Like Pierre was saying, if you had a peak up here, then maybe the exhaust valve isn't opening. You could look for any, and really seeing a known good. So if you have a good cylinder and a bad cylinder on an engine, pulling a known good waveform and seeing what it looks like and comparing it side by side, it makes it a no-brainer.
So that, you see, that is a very important part that you bring up there. Knowing and working on a known good is really going to help you to see what a bad is. So what you need to do is practice. If you don't practice, when there's a problem, you may not know there's a problem. So practicing is a biggie, right?
Absolutely.
You would all agree.
Yeah.
All right, so we're back. So you would all agree that knowing your particular scope, knowing your pressure transducer, knowing what to expect out of an exhaust pocket or an intake, checking the peaks. If you race this up, all the peaks should be even when you race it up, and let's kind of show that, because that could indicate we have a valve problem. So watch. Yeah, Pierre, see if we go up a little higher. You can see they're pretty much all even. And you can look at all your pockets as well. You're good, Pierre. Now what we can do, maybe Bill, is put it on, we're not on deep record, we're just on scope here. That way we can get some curses up on it. And anything else, Pierre, you want to kind of add to this?
Yeah, this is true of all scope usage, of course. You're looking for constancy or the
consistency,
lack of,
right?
Yeah, or the lack of it. Something that is doing the same thing every time, or sometimes it's not doing the same thing. I always recommend, if you don't exactly know that particular motor, but you only have, say, single cylinder issues, misfires, test a known, what you think is a good cylinder on the same bank. If it's a V engine, you want to test a cylinder on the other bank as well, just to compare them.
That's very, very important.
But you're going to do the same analytics over and over again. You're going to use cursors, like as Bill is doing here. You're going to get numbers on timing, value, and of course, you're going to maybe zoom out and see that they're all the same across a number of events. Now you see in this case, compressions are the same one to the next. But if you had a real high and a real low, real high, real low,
And we're looking at these lines, and also your pockets.
and the same thing with the pockets, that indicates a problem with, mechanical problem with consistent operation of the motor mechanically. You know, maybe it's got a bad lifter, or maybe it's got a valve that's either got a bad seat or a bad valve, or it's got a loose valve guide or carbon on the stem holding it open occasionally, whatever. Mechanical. At that point, you know it's mechanical.
And Bill, go over moving your cursors with the values here.
Okay, sorry, I'm just gonna zoom.
Yep, zooming in more.
Okay, first we go peak to peak,
So we can see our peak to peak, and
and then over on this, can you see my mouse?
yeah, you can see your mouse right here.
We have the period is 151 milliseconds,
Yep.
and you're going to divide that into 4, which this scope makes it easy because it has marked camshaft, and that breaks it down real nice for you.
So that's nice. All you got to do is hit mark camshaft here, and you got top dead, 180, 360, 540, 720, power, exhaust, intake, compression. And if your exhaust pocket is too far towards Pierre, too far towards my right,
That's advanced.
okay, that's advanced. Very important to know that.
Everything on a scope to the left is earlier and to the right is later. So advanced and retarded in timing.
And let's say if you're on VVT motors,
It might be programmed that
it
way.
may be programmed, so you want to check that out. Always check the amount of oil in the vehicle, and use your scan tool for bi-directional control to see some do some at idle, some will not move it at idle.
Right.
But you could do it by the tool to move it.
That's right.
In other words, you won't have being advanced at an idle on some vehicles with VVT, while others may, and you could control it through your scan tool.
And
to see if it
technically,
works.
If you want to put cursors on it and measure degrees, you could look in your factory part of the scan tool and see what the actual advance says it is, what the computer thinks it is, and compare it to what it's actually doing. Because there are cases where you'll have a single cylinder event, and you may or may not know about hydroformed or presto fit camshafts where one individual cam lobe could move in relation to the others.
The others. And that'll do you in.
And you could check cam timing marks all day long. The cam itself is lined up, but the lobe, that individual lobe, is not.
Very true. Anything else, Bill, you want to kind of say, or? So this Ditex, bring the little kit over with their cardboard doohickey. This is a good kit. Now, Bill, actually Franklin looked it up. He's not in our video here, but he looked this up. There's a guy in Ohio. What's his name? Mike in Ohio. What's the name of that company?
ATEC?
I think he wrote it down.
ATEC. A-A-T-E-C.
AATEC,
Yep.
right? So
Yeah.
Mike in Ohio, www.ATT,
A-A-T-E-C.
www.ATEC. Don't listen to this dope, okay? That's where you can get it here in the US, and it's made over in Europe, in Bulgaria. From what we've seen of the tool, for the money, I think it was how much?
$750 or so.
$750 is not a bad price if you price out anyone else's transducers. Again, we're not going to get in other names, but you know all the big names out there.
And especially if you already own a scope, you don't want to buy another scope.
This is a good starting point that won't break the bank. So I think here at TST, I think we give it the thumbs up, in my
Now I'm
opinion.
going to say this again. I'm going to say it a few times. You have to practice with whatever tools you own. So you buy this tool or any other tool. Taking it out of the box when you already have a big problem vehicle that's been to 6 shops, that's
Absolutely
a bad
wrong.
idea.
Bad idea. Super bad
The
idea.
best idea is to take a car that is, in your shop, maybe your own car, or better yet, if you want to really be dangerous, a car that's a wreck that's going to the junkyard so you can
Play
make a
with it.
mistake and not be worried about it, and test that car and learn the technique and learn what it looks like and learn how to use your tool, so that when you get a real trouble car, you'll be confident to pull that thing out of the box and use it.
And if you can get like the 3.5 Hondas that always need valve adjustments,
Right.
if you can get a vehicle with a valve adjustment,
Or even the early 4-cylinder.
loosen it up. Now don't be a nimnuts and think that a bad plug or coil or injector, this is not, this is mechanical.
Right.
Because it's a question that people always ask, I see it everywhere, and I don't mean to insult anyone out there, but please realize what it does. You need to practice, you need to RTFI, read the frickin' information, and the more you do something, the better you get at it.
And I like to tell the story. We have this comedy night, I call it, that we do with our friend and other board member, Eric Dibner. And we had a Honda 4-cylinder, you know, I forgot the year, but it had adjustable valves and a belt, a timing belt.
You guys beat the tar out of that.
And that was a wreck. It was going to the scrapyard. It was ruined, but it still ran. You know, we had to put a bucket under it for the coolant that was always coming out. But it was a mess. But we did that. We adjusted the valves, tighter, looser, retarded and advanced the cam timing, stuffed the rag in the exhaust pipe or in the intake, and looked at what the waveforms were. It was a good way to learn.
Yeah.
And if we had blown that motor up, so what? Going to the junkyard anyhow.
Practice makes perfect. And plugging the exhaust up, you do see it in the pockets.
Oh yeah,
That
you
is-
see it all. You see it in the pockets. You also see it like when you loosen valve adjusters. For example, you loosen the exhaust valve. Now that valve is going to open late and close early. So this is going to be to the right, and this side's going to be to the left of the same valve operation. Same idea with intake. You loosen it up, it's going to be later when it opens, and it's going to be earlier when it closes. And you're going to see shifting in the peaks and some other details as well.
Yeah. You may even see dips in compression,
And
obviously.
you'll see it'll affect compression, absolutely. Same with going the other direction, tightening it up too much.
And the clogged exhaust, right in here.
And if it's really plugged on the exhaust, you'll see a peak where it should not be here. And on a snap throttle, that peak may grow to the same height as your compression peak. It's really plugged.
Yeah, it grows extra peak.
Extra peak. And it confuses people. In fact, some people think that from here to the middle peak is 720 and they get confused. But just, you know, those are all things you have to learn as you practice. The idea is practice on a known good. If you can practice on a vehicle you've made known bad in some way, even better. Just not something you care about. You know, you don't do this on customer cars. This is,
No.
You know, this is,
Always know what to expect. When you know what to expect, it makes everything a lot easier.
and save data. I always recommend, first thing I do is hit save after I capture data.
And on any scope, Snap-on, Pico,
Doesn't matter.
you can save on every scope. Fluke,
And-
you can use it on anything.
And even if it's difficult on your scope to save screenshots, you know, take out your cell phone and save screenshots.
Very true.
Really quick, easy.
So this little quick webinar here brought to you by TST. And again, I want to thank Pierre and Bill, you know, and Franklin, who's not here, but was helping us before. Look it up. Again, if you want to buy that Ditex kit, you can basically go to
AA Tech.
AA Tech out in Ohio. He is the distributor for it. And for about $750, give Mike a call. Maybe not a bad way to get started. From TST headquarters here in New York, I'm G. Trulia.
And I'm Pierre Respo.
I'm Bill Fickthorn.
Have a good one. We'll see you next time.
Thank you.